We're on lesson 2 of unit 9, working with fractions. So our lesson today is on decomposing fractions. So remember, decompose means what? Decompose means to break apart. So we're going to learn how we take fractions like this and mixed numbers like this and break it up. So what do we see here? Well, we see 3 and 1/8. That means we have 3 wholes. So I see 1, 2, 3 wholes. And then we have this 1/8, which I see right here. So we could write that as 1 plus 1 plus 1 plus an eighth. Or remember, 8/8 is the same as 1 whole. So we could write 8/8 plus 8/8 plus 8/8 plus 1/8. So let's jump on in. Number 1. Draw a model to show one way to decompose or break apart 7/8. Well, we can break away 7/8 by putting 3/8 plus 4/8. But that doesn't answer our question because it's asking us to make a model. So what would that look like? Well, my model that I see up here, we have, so we can just write one like this. We can do 1, 2, 3 plus 1, 2, 3, 4. Now this might look, unfortunately, like 3 plus 4 since we don't have anything to compare it to. But that's going to be our model for right now. Number 2. Paul said the sum of 1/10 plus 7/10 plus 4/10 is the same as the sum of 5/10 plus 5/10 plus 2/10. Is Paul correct? Well, let's see. Let's add those up. 1/10 plus 7/10 plus 4/10. Remember, my denominators are all the same, so I just add the numerators. I just add those numbers up top. So 1 plus 7 is 8. 8 plus 4 is 12, so 12/10. So now let's check his other one. We have 5/10, he said, plus 5/10 plus 2/10. What does that equal? That equals 12/10. So yes, he was correct. And then our explanation is our math right over here. Number 3 through 4. For 3 to 4, decompose each fraction or mixed number in 2 different ways. Use drawings or fraction strips as necessary. So 3/5, I'm going to break that up. But before I even do, remember my denominators will always stay the same. So before I even do anything else, I can just fill those in without having to think. So now I think, how can I get to 3? Well, that can be 2 plus 1. And then over here, how else can I get to 3? But I have to have 3 numbers this time. So that could be 1 plus 1 plus 1. Off to number 4. So let's start with this one. Well, here I have 1 whole and 3/4. So I'm just going to write that 1 whole as a fraction. So 4/4, because remember, 1 whole is the same as 4/4, and then that would be plus 3/4. So I broke it up as the whole number and then the fraction. And now I can think, well, how else can I break that up? Well, I know 4 plus 3 is equal to 7/4. So this thing right here is 7/4. So how else could I get to 7? Well, I could do 5/4 plus 2/4. I could have done 1/4 plus 6/4. There's many ways I could have done it. So now let's head on to these bottom ones. And we're just going to follow that same pattern of how do we break these up. And notice they're going to have us do each fraction 2 times. So 4/6 could be 1/6 plus 3/6. Because remember, I add these to get that top number, that numerator. And then I can put those 6's in. And then how do I get to 4? Well, I could do 1 plus 1 plus 2 equals 4. Number 6, before I even start, I'm just filling in those denominators because they're always going to be the same. And now how do I get to 7? Well, that can be 1 plus 6. How else can I get to 7? Well, that could be 2 plus 2 plus 3. Again, there's many different answers you could do. Number 7, well, I have 1 whole, so I'm going to make that 1 whole over here. But before I even do that, remember, I'm just filling in those denominators. So 1 whole means I have 5/5, because remember, that's a whole. And then this other part would just be 3/5. So now, what is 5/5 plus 3/5? Well, that's 8/5. So I need to think, how else can I get to 8/5? Well, I could do 2 plus 1 plus 5 equals 5/5, or equals 8/5. That's one way. Over here, I have 2. Well, that's a little different this time because it's not just going to be 2 halves, because 2 halves would equal 1 whole. I need it to be twice as much. So it's going to be 4 halves. And why is that? Well, that's 2 halves plus 2 halves equals 4 halves, which is 2 wholes. So we have 4 plus 1. So that's one way. How else could we have done this? Well, 4 plus 1 is 5 halves. So how could we get to 5? Well, we could do 2 plus 2 plus 1. 2 halves plus 2 halves plus 1 half. Number 9. Put in those denominators. And then how can we get to 9? Well, that can be 5 plus 4. How else can we get to 9 with 3 numbers? Well, that one I'm going to just do 3 plus 3 plus 3. Over here I have 1 whole. And so what do we know about 1 whole? We know 1 whole is 3/3. And that just means this 1/3 is by itself. Now, 3/3 plus 1/3 is 4/3. So I can think, how else can I get to this 4? Well, I could do 1 plus 2 plus 1 equals 4/3. So today's lesson, pretty easy. So let's head on to our word problems now. Number 11. Jackie ate 1/5 of a bag of popcorn. She shared the rest with Arie. There's 3 ways they could have shared the remaining popcorn. So we have Jackie, and she could eat 1/5. Jackie eats 1/5. Jackie eats 1/5. But then she's going to share the rest. So what else could that be? Well, Jackie eats 1/5 and shares the rest. We could just say Arie gets the rest of it. We could say Jackie shared that 4/5, but she also ate another 5th. And Arie then got the leftovers, which would be 3/5. Or we could say Jackie was a pig and she ate 3/5, which then means Arie was left with 1/5. So that's one way they could have shared it. I don't really like how this question was written, but that's what we'd have. So we'd have, for our final answer, we have Jackie would eat 1/5, Arie would eat 4/5. That's one way. Another way is Jackie ate 2/5, Arie ate 3/5. Or our last way is Jackie ate 4/5 and Arie ate 1/5. So let's head to number 12. Draw an Arie model to show 4/10 plus 3/10 plus 2/10 equals 9/10. So if you remember from the previous one, I really didn't like the model that we had. So this one I'm going to draw, since I know it's tenths, I'm just going to draw tenths right here. So 1, 2, 3, 4, and 5. So we have 4/10, so I'm going to shade in 4. 1, 2, 3, 4. Then we have 3/10, that'd be 1, 2, 3. And our last one is 2/10, that would be 1, 2. And if we add all those up, we see, yeah, it does equal 9/10. So now off to number 13. In a class of 12 students, 8 students are boys. Write 2 equivalent fractions that tell which part of the class is boys. So we have 8/12. So let's make an equivalent fraction that has a larger denominator and one that is smaller. So our first is we could multiply by 2. So we could say 16/24. We could have also divided by 2. So 8 divided by 2 is 4. 12 divided by 2 is 6. You could have also had 2/3 for an equivalent fraction as well. Number 14. There are 45 girls and 67 boys at a sold-out concert. Each ticket to the performance costs $9. How much were all the tickets to the performance? Well, here we have 2 things going on. So I'm going to make a tape diagram. We have 45 girls and we have 67 boys. So I'm going to label it. So how many total people do we have? Well, we have 45 plus 67. So that's 112. And so now what do we know? Well, we know there's 112 people, and they each bought 9 tickets. So I could add 9 plus 9 plus 9 plus 9, but that's going to take forever. So I'm going to instead multiply. 9 times 2 is 18, regroup the 1. 9 times 1 is 9, plus 1 is 10, regroup the 1. 9 times 1 is 9, plus 1 is 10. So how much did it cost? Well, it cost $1,008 for all those tickets. Now our last one. Jason wrote 1 1/3 as the sum, important part, of 3 fractions. None of the fractions had a denominator of 3. What fractions might Jason have used? So, we're basically saying we have something plus something plus something equals 1 1/3. So what could that be? Well, we can't just have a third because it tells us. So let's make this an equivalent fraction. Let's change this to 1 and 2 6. Remember, we can multiply by 2 and 2. And now we solve that problem of what the denominator might be. So let's say 6. So now what could we do? Well, 1 whole we see. So that could be 6 6. And this fraction we can decompose as 1 6 plus 1 6. So that's one possible fraction that he could have used. And our last one. A teacher distributes a stack of paper to 3 groups. Each group receives a different amount of paper. Select all the ways the teacher can distribute the paper by decomposing 1 and 2/3. Use fraction strips if necessary. So what I'm going to do, because it helps me, is I'm going to rewrite 1 whole as 3/3 and 2/3, and then see what it is. So I'm looking for stuff that equals 5/3 or 1 and 2/3. So I see this one equals 1 and 2/3 because we have 1 whole and 2/3. I see this one right here does not equal it because what does this equal? This equals 4/3, so it won't be this one. This one right here, though, equals 5/3, which I see, remember, from right up here. This last one, we have 1, 2, 3, 4, 5. Ah, that's also 5/3. And our last one is 1 plus 2/3. So our answer looks like it could be all of these. Now, there is a problem, though, because it looks like it should be 5 1/3. But remember, there's only 3 groups. So right here, this is 5 groups. So our answer is actually not this one. Same thing with this last one down here. There's 2 groups here, and there's supposed to be 3. So remember, when you're doing your SBAC, they might have some questions like that, hey, it looks right, but it's really not.